Welcome to an exploration of the cosmic dance, where galaxies collide and merge in a spectacle of celestial grandeur. This isn't just a show of cosmic fireworks, it's a fundamental process that shapes the universe we see today. Galaxies aren't static, they're dynamic, always in motion, weaving an intricate ballet guided by the invisible hand of gravity. The universe isn't a serene expanse, it's an arena of galactic gladiators, where galaxies tussle and tango, sometimes embracing in a grand merger, or sometimes ripping each other apart. This dance is a story of transformation, of creation and destruction, of chaos and order. It's a process that's been happening for billions of years and will continue for billions more. As we delve into the mysteries of these celestial collisions, we'll unravel the dynamic nature of galaxies and the cosmic forces that drive them. Join us as we unravel the mysteries of these cosmic collisions. Galaxies, like stars, are not static. They are in constant motion, guided by the invisible hand of gravity. Picture a dance, a celestial ballet on a universe-sized stage, where galaxies pirouette, leap, and twirl in an intricate choreography dictated by the forces of nature. These celestial bodies, comprising billions of stars, dust, and dark matter, are not merely drifting aimlessly in the cosmic ocean. They are engaged in a dynamic dance, their paths and interactions governed by the fundamental principles of galactic dynamics. At the heart of these principles is gravity, that invisible force that holds the universe together. Gravity is the puppeteer pulling the strings, dictating the motion of galaxies, shaping their paths, and determining their fates. It's the force that draws galaxies together, causing them to interact and, in some cases, collide and merge. But galaxies are not passive dancers. They are dynamic entities, their movements and behaviors influenced by their own mass and shape, as well as the presence and influence of other galaxies. The spiral galaxies with their swirling arms, the elliptical galaxies with their rounded, elongated forms, and the irregular galaxies with no distinct shape. Each moves and interacts in its own unique way, adding further layers of complexity to the cosmic ballet. It's a dance that's been going on for billions of years, ever since the first galaxies formed in the early universe. And it's a dance that continues to this day, with galaxies moving and interacting, colliding and merging in a never-ending cycle of creation and transformation. The study of galactic dynamics, therefore, is not just about understanding the motion of galaxies. It's about unraveling the story of the universe, decoding the cosmic dance, and peering into the past to glimpse the future. Gravity, the cosmic puppeteer, orchestrates this celestial ballet. And in that dance, we find the story of the universe, written in the motion of galaxies. When galaxies draw near, their mutual gravitational pull begins to distort their structures, creating a cosmic tug-of-war. This is where the role of tidal forces and gravitational interactions comes into play. Imagine two galaxies, each a swirling whirlpool of billions of stars, gas, and dust. As they venture close to each other, they don't just pass by unscathed. Instead, they engage in a celestial dance, orchestrated by the fundamental laws of physics. The gravitational pull between them creates an intergalactic tug-of-war that can dramatically reshape these galaxies. Now let's delve deeper into these gravitational interactions. Picture the galaxies as two dancers twirling in a grand cosmic ballet. The closer they get, the stronger their gravitational attraction becomes. This force isn't uniform, though. It's stronger on the side of each galaxy closer to the other, and weaker on the opposite side. This difference in gravitational force, known as a tidal force, can stretch and squeeze these galaxies, pulling them out of their usual shape. Here's where it gets even more interesting. The mutual gravitational pull doesn't only affect the shape of the galaxies, it also influences their internal dynamics, stirring up the gas and dust within them. This can spark bursts of star formation, lighting up these galaxies like a cosmic fireworks display. But that's not all. The gravitational interaction can also strip away stars, gas, and dust from these galaxies, creating long streams of material stretching out into space. These structures, known as tidal tails, bear testament to the intense gravitational tug-of-war that these galaxies have experienced. In some cases, if the galaxies are close enough and their mutual attraction strong enough, they might eventually merge, forming a single larger galaxy. This process can take billions of years, but it's a fundamental part of the life cycle of galaxies. This gravitational dance leads to a dramatic reshaping of galaxies. It's a testament to the power of gravity, the fundamental force that shapes the universe as we know it. Galactic collisions are not instantaneous events, but a gradual process unfolding over millions of years. Indeed, the dance of galaxies is a spectacle that plays out in the grandest of scales and over vast stretches of time. It's a cosmic ballet, choreographed by gravity and enacted by celestial giants. The first stage of this cosmic drama is the initial approach. Two galaxies, drawn together by the irresistible force of gravity, begin to feel each other's influence even when they are still millions of light years apart. This is the slow and steady build-up to the main event, like the tension mounting in a theater before the curtain rises. As the galaxies draw closer, they enter the second stage, the tidal interaction phase. The gravitational pull of each galaxy tugs at the other, distorting their shapes and pulling out long tendrils of stars and gas. These tidal tails stretch out, a testament to the powerful forces at play. The third stage is the first close pass. The galaxies, now distorted by tidal forces, swing past each other. This close encounter triggers bursts of star formation as gas clouds in each galaxy are compressed. The galaxies, though scarred and changed, are still separate entities at this point. The fourth stage is the second close pass. The galaxies, having swung out in long elliptical orbits, are drawn back together. This stage is a repeat of the third, but with one crucial difference. The galaxies have lost energy in their dance, slowing down and making it harder for them to escape each other's gravitational pull. The fifth and final stage is the merger. The galaxies, unable to escape each other, merge into a single larger galaxy. This process is violent and chaotic, with stars flung about and supermassive black holes at the galaxy centers potentially merging. The end result, however, is a single, stable galaxy. Each stage of the collision tells a story of cosmic transformation. It's a tale of gravity, motion, and change, all playing out on a stage as vast as the universe itself. Galactic collisions are not just destructive, they can also trigger a burst of star formation and awaken sleeping giants at the galaxy's core. When galaxies collide, their gas and dust clouds can become compressed. This compression initiates a domino effect, leading to the birth of new stars. Picture this: the intense gravity during a collision acts like a spark, igniting a stellar nursery where new stars are born out of the cosmic dust and gas. But that's not all. These collisions can also stir the dormant monsters lurking at the heart of galaxies, the supermassive black holes. Now, these black holes aren't always active. They're like sleeping giants, quietly minding their own business until something disturbs them. And a galactic collision, well, that's a pretty major disturbance. When galaxies merge, the gravitational disruption can send a flood of material towards the supermassive black hole at the center. As this material gets closer to the black hole, it forms an accretion disk, a swirling disk of gas, dust, and stellar debris. This accretion disk heats up due to the immense gravitational pull of the black hole, and it begins to glow brightly. This glowing accretion disk is what we observe as an active galactic nucleus, or AGN, a beacon shining from the heart of a galaxy. So, while galactic collisions may seem like cosmic catastrophes, they're also catalysts of creation, sparking star formation, and firing up the engines of supermassive black holes. They remind us that even in destruction, there can be creation, and in the darkness of space, new lights can be born. In the chaos of collision, new stars are born, and dormant black holes awaken. These are the dual faces of galactic collisions. Destructive, yes, but also dazzlingly creative. As we continue our journey through the cosmos, let's remember this duality, the yin and yang of the universe shaping galaxies across the cosmic sea. At the heart of every galaxy lies a supermassive black hole. What happens when two of these cosmic behemoths come together? Just like galaxies, supermassive black holes can collide and merge too. This cosmic event is one of the most powerful phenomena in the universe, releasing a tremendous amount of energy and sending ripples through the fabric of space-time itself. When two galaxies begin their celestial dance, nearing each other due to gravitational forces, their supermassive black holes start feeling each other's pull. As the galaxies merge, the black holes sink into the core of the new galaxy, drawn together by a force known as dynamical friction. This force acts like a cosmic brake, slowing down the black holes and causing them to fall towards each other. The black holes then engage in a gravitational waltz, orbiting each other and shedding orbital energy. They move closer and closer, their speeds increasing until they're whirling around each other at near light speeds.
This final stage, known as the inspiral, is a furious and violent dance that can last millions of years. As the black holes draw nearer, they start to stretch and distort each other's event horizons in a process known as tidal deformation. This intense gravitational interaction leads to the emission of gravitational waves, ripples in space-time, that race outwards at the speed of light. Finally, in a cataclysmic instant, the two black holes merge, forming a single, even more massive black hole. This event, called the coalescence, releases a colossal burst of gravitational waves that can be detected across the cosmos. The newly formed black hole then settles down, its event horizon smoothing out and its spin slowing, a phase known as the ring down. It's like the ringing of a cosmic bell, signaling the end of the merger and the birth of a new, more massive black hole. These events are not just theoretical. Scientists have detected the gravitational waves from merging black holes, providing us with a new way to observe and understand our universe. The merger of supermassive black holes is a testament to the unimaginable forces at play in our universe.
Galactic collisions are not just destructive, they can give birth to a new kind of galaxy. This might sound surprising, but it's a fascinating reality in our dynamic universe. When galaxies collide, the result can be the formation of a new galaxy type, known as an elliptical galaxy. Elliptical galaxies, as the name suggests, have an oval shape, unlike the pinwheel structure of spiral galaxies. They are typically the product of a grand cosmic dance between two or more galaxies. As spiral galaxies draw closer and begin to interact gravitationally, they start to lose their distinct, ordered structures. The gravitational pull between them disrupts the spiral arms, causing stars, gas, and dust to scatter in all directions. This scattering process is incredibly chaotic, but it's also a catalyst for change. Over time, the scattered material starts to settle and reorganize itself under the influence of gravity. The outcome of this reorganization is what we call an elliptical galaxy. The transformation from spirals into ellipticals doesn't occur overnight. It's a process that plays out over hundreds of millions, sometimes even billions of years. And it's not a process that happens in isolation. Each galactic collision is a unique event, influenced by a multitude of factors such as the size, mass, and relative speed of the colliding galaxies, as well as the angle at which they collide. But it's not just the shape that changes. The content of the galaxies also undergoes a significant transformation during a collision. In particular, the rate of star formation often experiences a dramatic increase, followed by a sharp decrease as the available gas and dust are used up. As a result, elliptical galaxies tend to be populated by older, redder stars and are often referred to as red and dead. In the aftermath of a collision, a new galaxy is born. This birth, while violent and chaotic, is a testament to the ever-changing nature of our universe. It's a stark reminder that even on a cosmic scale, change is the only constant. Galaxy collisions are not isolated events. They play a crucial role in the evolution of the universe. These cosmic encounters are more than just spectacular displays of galactic dynamics. They are, in fact, fundamental to the growth and transformation of cosmic structures. Every time galaxies collide and merge, they reshape the cosmic landscape, giving birth to new galaxies, igniting new stars, and even stirring up the supermassive black holes at their centers. This process of creation and transformation is a key factor in the evolution of the universe. It's how galaxies grow, change, and ultimately, how they shape the universe we see today. These galactic collisions are a testament to the dynamic nature of the cosmos, a universe in constant motion and change. As we continue to study these cosmic events, we gain deeper insight into the grand narrative of our universe. Through these cosmic collisions, we glimpse the grand story of our universe. Galaxy collisions and mergers are a testament to the dynamic nature of our universe. We've journeyed through the cosmic ballet of galaxies, from understanding the fundamental role gravity and tidal forces play in these celestial dances, to marveling at the stages of a galactic collision. We delved into the explosive effects these cosmic events have on star formation and the activation of active galactic nuclei. We explored the dramatic merging of supermassive black holes at the heart of these celestial bodies. We saw how these cosmic encounters shape the very fabric of the universe, leading to the birth of elliptical galaxies. And finally, we touched on the profound significance these events hold in the grand evolution of the cosmos. As we continue to gaze into the cosmos, we look forward to unraveling more mysteries of these celestial dances.